Alrighty, so here we go. We are now on Linux Fundamentals Part 2. So we're continuing your journey learning Linux. You'll be learning how to log into a Linux machine using SSH and how to advance your commands in file system interaction. So there is a good video. It's
Hey everyone,
2 minutes. You are more than welcome to go ahead and watch that. What we are going to do is we are going to say, there's a machine that we can start, so we'll go ahead and hit start machine right there. And this one is actually a little bit like how most TryHackMe labs are actually going to be, where you have a target machine that's going to spin up, and we are going to start our attack box as well. So it's going to jump into split screen shortly. There we go. Let's get back into introduction. So welcome to the second part of the Rework Linux Fundamental series. We'll be applying our knowledge from the first installment of the series, so I highly recommend you to complete that room. So hopefully you all did that. In part 2, we'll be ditching the in-browser functionality and help you get started with what is a fundamental school, which is being able to log in and control terminals over remote machines. Not only in this room, or blah blah blah, pretty much in this room, we'll be unlocking your potential of your first few commands by introducing you to flags and arguments, like switches and stuff, advancing your knowledge of the file system to perform some of the more useful commands such as copying and moving files, and discovering how to access files and folders, or how access to files and folders is managed and how we can determine our access. Then we also get to run our first few scripts in executable, so that seems fun. Let's go ahead and hit correct answer. Now the first thing that we're doing, so we already did this, but we deployed the Linux machine, which was with that little start button, and then the TryHackMe attack box, which we did up here, which is still loading up. Alright, so what is SSH? SSH is secure shell, and it's simply a protocol between devices in an encrypted form. So using cryptography, any input we send in a human readable format is then encrypted for travel over a network, whereas then unencrypted once it reaches the remote machine, such as in this diagram. So we have my computer is sending hello world. The internet, however, sees this garbly goop of data right here, and then the Linux server decrypts it, or it's unencrypted, and it'll say hello world for it. So we can learn about the various types of encryption on TryHackMe Room, but for now, we only need to understand that SSH allows us to remotely execute commands on another device remotely. Alright, and any data sent between the devices is encrypted when it's sent over the network, such as the internet. So, sweet, our attack box is up. We're going to go ahead and hit the Enter key. Welcome to Ubuntu. So this version of Linux, this distro, it's still Ubuntu. We did Ubuntu in the last one, but this one has a GUI. So we're going to go ahead and click on Terminal to start. Let's see, so we learned how to deploy TryHackMe attack box. Hopefully you have a screen much like this. Next, it's going to tell you how to SSH into your Linux machine. So the syntax is very easy. You're going to use SSH space the username at the IP address. So for this one, if we look, this is an example. So SSH TryHackMe. So the username is TryHackMe and the password is also TryHackMe. Let's see if that is our IP address, 10.10.181.251. So that's our Linux box that we're going to be SSHing into. Our attack box has a separate IP up here, which is 10.10.32.209. Alright, so in this case, we just need to know this one. And I am curious, is it the same 10.10.181.251? It is. Cool. So you can just read it right here. So we're going to do SSH TryHackMe at 10.10.181.251, and it will say, hey, are you sure you want to continue connecting? We can hit yes, and now it's going to ask for your password. So here it says the password is TryHackMe, and if you notice, I'm typing, but nothing's appearing in the password field over here. That's how Linux typically operates. Alright, if you're typing a password, it's not going to show you the asterisk or little circles like in Windows or on Mac. It's just there. So let's hit enter. Hopefully I typed that in right, and I did. Alright, so now in our terminal it says we're logged in as username TryHackMe at Linux2, and bada bing bada bam, that should be where we're at. So if you do that, congratulations, you have now SSH into your first box. So good job. We're going on to task 3, which is introductions to flags and switches. So a majority of commands allow for arguments to be provided. So these arguments are identified by a hyphen and a certain keyword known as flags or switches. So for example, earlier we learned about ls, right? So if we do ls, it will show us in this directory we have important, my file, my folder, and unknown. But if we do ls-a for all, we have a lot more that's being displayed. So if you've ever navigated in Windows and if like you're trying to find the app data directory, you have to go into the little option, say view hidden items and folders. That's kind of what all is doing right here, is it's displaying things even with a hidden property. And if you notice, we have a couple of entries that have periods in front of them. All those are hidden files. All right, so bash underscore logout, bash rc.cache, profile, all those are hidden. Oh, sorry, got a spam call. But all those are hidden files. All right, and another very, very, very useful command is going to be, or I'm sorry, not command. We are talking about flags and switches. So this flag of tac help. So this will tell you whatever command that you're doing should also have some help documentation associated with it. So it's saying here is the usage. So that's the syntax of it. ls space the option. So if you have any flags or whatever, and then space the file. All right. So we can have tac A for all or capital A for almost all. You can do 2 tacs for author, escape, ignore backups, color, directory. It goes on and on and on and on. Tac H is human readable, so that's a good one just for syntax. But it goes on, and for nearly all commands, they should have a help area as well. So just remember that is your command, then space tac help. So if you're ever confused, if you're ever lost, go ahead and just ask it for help. Now, there is also available documentation through the manual, which this time instead for the command being in front, you do man space then the command. So this is a little bit different. It's still like it's better formatted. All right, it really is. All right, but to go through it, we can hit down, we can hit up, and then we can press H for help or Q to quit. So let me go ahead and hit Q to quit, and it just brings it back and it just kind of shrinks it away. All right, so it says explore the manual page of the ls command. We just kind of did that. What directional arrow key would you use to navigate down? And we would use the down key. And which flag would we use to display the output in a human readable way? So the flags can start with the tac, little hyphen, and if we remember that H was for human readable, so there we go on that guy. All right, moving on to task 4, we're going to go over some more commands for interacting with the file system. So we're going to go over how we can create files and folders, how we can move them and delete them. So there's 6 right here. Go ahead and copy and paste those into your notes. So we have touch, which will create a file. mkdir is make directory, so that makes a folder. cp stands for copy. It will copy a file or folder. mv is for move. It's moving a file or folder. rm is removing, so that's how you can delete. It removes a file or folder, and file determines the type of a file. All right. So we now go through a couple of examples here. So this one's using touch. So touch, note, and then they list the directory, and we now have a note file right there. This one is making a directory with mkdir, so make directory, and they're calling it my directory. And then when they do list, you now have a folder in there that's called my directory. And then they're removing files and folders, so they can do, like if you just do rm note, then it's removing a file. But if you do rm space, then this flag right here, which is hyphen capital R, then it can remove a directory. Okay, so you can't just remove the directory, you need that flag on it. Next up is copying and moving files and folders. So with copy, you're going to do a syntax of, let's see, hold on, I want to make sure I'm saying this right. All right, so it's going from note and it's copying over to note 2. So note exists, you're copying over into note 2, you're copying it, and then move is moving, like, what is the best way to put this? So you can rename stuff through move. So reading through this, moving a file takes 2 arguments, just like the copy command. However, rather than copying and creating a new file, move will merge or modify the second file that we provide as an argument. So not only can you use move to move a file to a new folder, but you can also use move to rename a file or folder. For example, in the screenshot below, we're renaming the file note 2 to be named note 3. So note 3 will now have the contents of note 2. All right. And then we have determining file type, and you use that with the file command. So we have a couple questions here, which we will now be able to use what we just learned in practice. So how would you create a new file named new note? So to create a file, we use touch, and then the name of it is new note. So that's how we'll do that. On the deployable machine, what is the file type of unknown in TryHackMe's home directory? So if we do ls, so we see unknown 1, and to determine the file type, we use file, and then we're going to type unknown 1, and it is an ASCII text file. So boom, ASCII text. And how will we move the file my file to the directory of my folder? So we would do mv for move, then we'll do my file and tell it to go to my folder, just like that. So it's not rocket science, it just takes a little bit of time to get used to. And then it says what are the contents of this file. So if we remember how to read a file, we use cat, and we want to read my file, and it says this flag of thm file system. Cool. And then it says continue to apply your knowledge and practice and commands from this task. So go ahead, take a few minutes, interact with these move, copy, remove files, things like that. Just bounce back and forth, get a little bit comfortable. And if you do get lost, remember you can always do pwd to tell you where you're at. The home directory that you at least started was home/TryHackMe. Next up, let's talk about permissions. So, as you have already found out by now, certain users cannot access certain files or folders. We previously explored some commands that can be used to determine what access we have and where it leads us. So in our previous task, we learned how to extend the use of commands through flags and switches. So if we're talking about that ls command, which lists content of the current directory, when using a TACL switch, we can see 10 columns, such as in the screenshot below. So let's go ahead and do that as well. So if we do ls-l, alright, the 10 columns that's talking about is the stuff on the left where it's like tac rw, tac r, tac r, tac. Alright, and for each folder, it has these. And what these do is it's stating who has read, write, or execute permissions. So in Windows, you can right click on a file, go to Properties, Security Groups, in the Security tab, and you can see what users or groups have read, write, or execute, as well as who's the owner. With Linux, you have these columns right here. So let's go ahead and read this so that we're not skipping out, because this is fairly important. The great thing about Linux is that permissions can be so granular that while a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. So let's put this into real world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will want to have will have to want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. That makes sense. All right. So we'll learn the commands necessary to switch between users below. So it looks like we're not going to go too deep into these permissions right now. We're going to talk about how to switch users. So just know Linux can be more granular than other systems when it comes to file permissions. We'll have more experiences with this. Don't worry if you're not grasping it completely right now, but just understand it's going for read, write, and execute between right now. It says we're only interested in the first three, but they just apply for different sets. All right. So switching between users, that's easy to do. We use the SU command to do so. So unless you're the root user or using root permissions, in which case you can do it through sudo. All right. So you are required to know two things to facilitate the transition of user accounts: the user we wish to switch to and the user's password. So you can use SU and then their username, and then you can put in their password. They are talking about using the TACL switch. So this first one looks completely normal. You know, SU user 2, so they're going to user 2. They'll put in password, and then brings them to home/TryHackMe. But it's not really saying user 2 there. But if you use the TACL switch, so SU space TACL, then space user 2, put in their password. And then if you PWD, it will say, you know, your user 2 home/user 2. So it will automatically put you in the home directory of that current user. So let's go ahead and see on the deployable machine who is the owner of important. Let's see. So when we did this, user 2, because that's who it states right there. All right, as opposed to TryHackMe, which is for my folder, my file, and unknown one. Okay, so user 2, that's the owner for that file right there. So what command would you use to switch to user 2? We would do SU space user 2. So now it's telling us switch to user 2 using that command. Boom. And then the password says over here is user 2. So sweet, we're in. Then it says output the contents of important and what is a flag. So do we remember how to output stuff? That's with cat. And we want to go ahead and output important, and there you go. There's that flag of THM SU underscore user 2. So we are going strong. Good job, everybody, for getting that. We are on common directories. So here we're going to talk about important directories to a Linux operating system. Looks like we're going to go over 4 of them. The first one being the etc directory, which is the root directory. So it's short for etc. And it's a common place to store system files that are being used by your operating system. So for example, the sudo orders file highlighted in the screenshot below contains a list of the users and groups that have permissions to run sudo or a set of commands as the root user. Also highlighted below are the passwords, so PAS, WD, and shadow files. These 2 files are special for Linux as they show how your system stores the passwords for each user in an encrypted format called SHA-512. Alright, so the etc folder, fairly important. Next up, the var directory, which is short for variable data. So that's when the main root folder is found on a Linux install. This folder stores data that's frequently accessed or written by services or applications running on the file system. For example, log files from the running services and applications are written here, and /var/log, or other data that is not necessarily associated with a specific user, like databases. So I like to think of it like RAM, where it's temporary, but that is another very important directory to know about. Next up is the root directory. So unlike the home directory, the root folder is actually the home for the root system user. There isn't anything more to this folder other than just understand this is the home directory for the root user, but it's worth a mention as a logical presumption that this user will have their data stored in a directory such as home/root. It's not there. It is over in the root folder itself. So over here, like on TryHackMe, on this user, it would be in home/TryHackMe or home/user2, but for the root user, it is just in /root. All right, and oh my God, I got things mixed up. I apologize. Earlier I said /var was like RAM. I'm sorry, that is not correct. /tmp is the one that is like RAM because it's the temporary root directory. So my bad on that, guys. We all make mistakes as long as we can learn from them, right? So this is a unique root directory found on a Linux install. It's short for temporary and is volatile and is used to store data that is only needs to be accessed once or twice, similar to memory on your computer. Once the computer is restarted, the contents folder are cleared out. So what's useful is for us in pen testing is that any user can write to this folder by default. I mean, once we have access to the machine, it serves as a good place to store things like our enumeration scripts. So now we have a good destination of where we can be putting scripts into, which is the /tmp folder there. So let's go ahead and answer these questions. README, correct answer. What is a directory path that we would expect logs to be in? So that's at /var/log. And what root directory is similar to how RAM works? That's going to be this volatile one, which is TPM. And then name the home directory of the root user, and we learned that that is at root. Alrighty, so we learned some very important directories. Cool. Now we can apply our learning and navigate through these directories on the deployed Linux machine. So you guys can go ahead, mess around in the Linux machine, go left, go right, start seeing what's in these common directories. Alright, so remember, you can use cd to navigate, you can use ls to list what's in them. Alright, next, our conclusion. So this room was quite theory heavy and covered quite a range of the fundamentals, getting you familiar with Linux. To quickly recap, we have learned how to SSH into a Linux machine. We've learned advanced commands by providing flags and switches. We've learned some more commands that you'll be using frequently to interact with file system and content. We've done a brief introduction of file systems and switching users, and a summary of the important root directories of Linux. Alright, so with that, let's go ahead and terminate our machine. Then we can join the next room. Up if it wants to, if it wants to, if it wants to. Maybe it does. Alrighty. With that, congratulations on completing Linux Fundamentals Part 2. Good job, everybody. I hope you guys had fun in that room. We have one more in the Linux Fundamentals series, so I'm going to keep on going. Hopefully I'll see you in the next video. Thank you all for watching.